Hello, everybody. My name is Tijmen Schep, and I'm going to give you a short talk about How Normal Am I, which is a project I've been working on, which explores face recognition and face detection algorithms. It's actually live right now. It's been live for the past 30 minutes, so you're the first ever people to be able to try it. But before you do that, let's get into it. So what I want to do to you with you in this talk is give a little bit of an introduction who I am and what this is all about. Then we're going to have a demo, which means that I'm going to give you 8 minutes to actually try it. So I've timed it. It takes about 8 minutes. It's an interactive documentary which will, measure your face and well, you'll see. I don't want to give away too much because it's quite a lot of fun. There's a lot of little hidden things in there. I wonder who of you will find them. Then after that, I'll go into how it was made, and I'll focus on one specific algorithm, which is an algorithm that tries to analyze your body mass index from just looking at your face. So that's in there as well. You'll experience that. And after that, I'll try to just go a little bit into the bigger picture, very shortly, like why should we care about this? What's this all about? All right, let's start with the introduction. So I'm a technology critic and a privacy designer and also an artist. So I enjoy working between these fields. And on the one hand, as a technology critic, I'm more into the theory and the philosophy of things. And as a privacy designer, I get very hands-on and try to help organizations make privacy-friendly products and just make it very tangible. So I find that I oscillate between being very philosophical and very hands-on nerdy programming, and that I really enjoy being in between those worlds. And that being in between those worlds often gives you very useful insights that you might not have if you're just in one of them. I wrote a little book about privacy design in 2016. It's used by a lot of schools in the Netherlands as well as in Germany. I recently learned to teach the subjects, and yeah, it's one of the things that I'm quite happy with, quite proud of, and it's quite useful. And check it out. I don't make any money from it, and don't worry about that. One of the things I've been working on lately, and that's also related to what we're talking about today in a way, to Sherpa, is a privacy-friendly smart home called Candle. And that's more of a project that explores how can you make these issues around privacy and surveillance tangible, and how can you offer a solution and show the world that it can be done differently. So I worked together with some designers and artists and privacy experts, and we actually created a very nice and easy-to-use privacy-friendly smart home prototype. It was launched on Dutch Design Week in last year. We won a Dutch Design Award for it as well. A national Dutch Privacy Award for it. And we're in the running for a Dutch Design Award. So it's all quite exciting, and this project is ongoing. Another project in this area that I work on is called Privacy Label, and that's more of a project that tries to summarize privacy statements in one short A4 style overview. And well, that's another just one of these things that's about privacy design, and what you really find is you really need to understand both what privacy is, the technological areas, the law aspects of it, the judicial aspects, but also ask yourself, what does my mom want to know? What does my mom understand about privacy, and how can I help her understand that? And I guess with that, we slowly get to the project we're going to talk about today, which is also very much about that question of how can I help my mom understand what's going on with these surveillance and face recognition systems in a fun and accessible way. So the project we're going to talk about is part of my work for the Sherpa project. So I'm an artist with this consortium, which is mostly a lot of universities. And they've been tasked by the European Union to explore these issues of what's going to happen with artificial intelligence and smart information systems towards the year 2025. So what are the very practical the issues that we're going to run into? And that's where it feels like, education and electricity grids and healthcare and all these types of issues and areas where you can, kind of see and foresee what the issues are. And this consortium asks basically, a lot of people for their opinion and tries to collate that all and then present that to the European Commission to say, hey, these, according to the experts and people in the field, is what the issues will be in 2025. And this is what you could do about it. And as an artist in the consortium, I'm kind of the odd one out. I have an interesting role where I'm allowed to reflect on what they do. And How Normal Am I, which is the project we're talking about today, is in a sense also a reaction to that, where we're looking at it from my mom's perspective. I don't think she looks at these issues around artificial intelligence from these, the sectoral approach. I think if you ask my mom what the big issue around artificial intelligence is, or what I feel it will be for her, is that she's being profiled a lot. That we're getting these profiles and all these predictions made about us, and those increasingly influence our chances in life. And it's not just about showing you ads, but it's about a lot more than that. And yeah, that's what I wanted to visualize and help my mom understand, while at the same time also making that point that I think this profiling aspect is something we have to look at more, and I hope to contribute to that from my perspective. So like I said, I'm the artist of the bunch. Another, for example, weird project I'm doing for Sherpa is creating smart water guns. Actually, right now it's just normal smart nerf guns, which again is based on image recognition and face recognition. So these are nerf guns that can automatically shoot people of certain persuasions or types in society if they swerve in front of the gun. So for example, it can automatically shoot women, or only shoot men, or only shoot baby boomers, or only shoot children. So these are guns that are kind of playing with this idea of warfare and automating that. So that's another of these areas that Sherpa is looking at. What are the artificial intelligence issues around warfare? And for me, looking at this rising field of smart guns is very interesting. For example, Samsung is actually making smart guns that they've already deployed at the border between North and South Korea. It's called the Samsung SGR-A1, if you want to look it up. And so it's a real smart gun, and that's being sold, and it can already has the option to automatically shoot people using face recognition software. So this stuff is very real already, in a sense. So we finally arrive at what we're going to talk about now, which is How Normal Am I? And How Normal Am I is a project that, like I said, tries to measure your face in all kinds of ways. And right now we're going to have the official launch. And I don't want to give away too much, but what you'll see is that you won't just be measured. Your face won't just be analyzed, but you will also be compared to other people who have also done this test, or who are also doing it. So yeah, I don't want to give away too much. So I say, let's do it. I'm going to ask you all to open another browser window and go to HowNormalAmI.eu. And for the next 8 minutes, just try it and do it for yourself. And I'll patiently wait. And when you get back, I'm sure there'll be some questions, but I'm going to go into in depth in what you've just experienced. So I say, have fun. So has everybody finished it by now? I see some people who have a score now, so that's a good sign. Is everybody ready? Great. Okay, I'm going to assume that everybody's done and that we can continue. Yes, I see a lot of scores coming in. Great. Okay, so I'm going to go jump back into Keynote, and we're going to continue where we left off. Was anybody violently normal? That's always fun. All right. So I assume you've all done it, and you probably have some questions, and I'd like to get into those at the end. But for now, I'm just going to quickly continue and give you some sneak preview or some making of aspects that I wanted to share, because it was actually really interesting to make this thing. So the making of, well, to be completely clear, it actually started out with the Dutch version that I originally made together with the Hogeschool van Rotterdam and the Practical University of Rotterdam, as well as the province of the south of Holland, and they're mentioned at the end. So this was a translation and an expansion in which some things were added. So that's why I also want to talk more about this expansion, which for me was very interesting to do. So most of this, what you just saw, was made using ready-made algorithms, off-the-shelf things that I actually literally found on GitHub. So How does that work? Well, you go to github.com and you search for things. You search for projects like face plus BMI, and you find all these projects that that use face detection to predict BMI. Not all of them, but there are quite a few. So I downloaded them, looked at their code, tried to get it running, but also to see where they got their pictures. I just analyzed it like, thoroughly. And I think I must have like looked at some 30 projects that did this particular aspect of looking at your face to BMI, how that's related. Most of the time, you just find ready-made models. A lot of them, assume you will create your own, but they also provide ready-made models. And those are the ones, when I found some smaller ones that are easy to download, I used those and implemented those. Those were built on top of another project called Pineapplejazz, which is this web-based face recognition tool, which is absolutely amazing. So I expanded on that, and that together was the brunt of it. However, I made one of these myself, and that was really fascinating. That's what I did for the expansion, and I want to get into that one. So that's the one that measures tries to predict your BMI. So yeah, I already have to be careful with saying that it measures it, because of course it doesn't measure that. It tries to predict it, and often fails horrifically at it. And I know it does because I made it myself. So I know all the flaws that this algorithm has, and I want to dive into that. By the way, something you'll have noticed in what you just experienced is that I never use the word artificial intelligence. I really consciously try to avoid using that, because for me, that word is so laden with, all kinds of levels of assumptions about what it is. Some people think of consciousness level artificial intelligence that we're moving to. And for me, what I try to usually do is, instead of using the word artificial intelligence, I try to say statistics on steroids. Because once you start building this and understanding how it works, you really see that that's what it is. It's just statistics really on steroids. There's nothing really intelligent inherently about it. It's amazing and well, clever how it works. But once you see all the steps, it's really statistics. And what do we know about statistics? You got statistics, more statistics, and you can lie with them quite easily. And that's what these things do. It's been extremely educational for me to do this, and I hope to bring some of that across to you. I liken it to going on a safari. So when I go to GitHub and look at all these things, it feels very much like you're spotting these wild animals, and because they're so different. Like some projects come, for example, from America, as you'd expect, but they're surprisingly, a lot of them come from India and China. Specifically, I find the ones that come from India, the projects who share their code online from China, very interesting, because it's actually one of the few places, when you think about it, where you can get such an insight into Chinese culture, since China usually has their own social media networks, for example, but they still share GitHub with us. So GitHub is this thing where you can get an insight into what Chinese makers are doing. And that's why you find a lot of Chinese projects. And that's also why a lot of the projects that make me go, ooh, are quite often Chinese. So let's dive in. So to understand this face to body mass index algorithm, it's important to first know what a body mass index is. And of course, you might know from school, like, it's this ratio between your weight and your height. So it has something to do with that, which is true. But it's also a lot more complicated than that, because your BMI is not universal. You can't just compare it between people that easily. And you can't just create one size fits all out. So an algorithm that just looks at men or women indistinctly and then creates one, that's very dubious. That's what my algorithm does, though. It doesn't really make any distinction between men and women. It creates like one score no matter what you put in. But technically, it would be good if you actually created two algorithms, one for men, one for women. And then there's a lot of other things that really matter. For example, there really are. By the way, men have slightly wider faces, so that's one of the reasons why you can't really compare it that easily. But culture is also a big one. Culture has actually influence on BMI scores, and sports as well. For example, with sports, you might understand that muscle mass is a lot heavier. So what you get is that athletes have a surprisingly high body mass index, which we associate with being unhealthy, but actually they're really healthy. So you get this weird thing where I'll get into a little bit later about where you get the data to train these algorithms. But for example, data from sports websites, from athletes' indexes is scraped and used to create these algorithms, which means that, yeah, you already get these really weird discrepancies in there. But I'll get into that. I'm jumping ahead of myself. So here you see an example of how not to take this, how to do this well. And this is from a Chinese project. And you see on the right that essentially people are classified into 3 groups. And it's just, everything's chucked in there and you're either fat, normal, or thin. That's it. So that's, if you train an algorithm to put people in these 3 scores, that's not going to be very precise. But you find this stuff a lot. And, one of them that I found is slightly more complicated, for example. So it has fat, little fat, normal, thin, and very fat. And but that's so incredibly simplistic. But yeah, you find these, and these are used for things. And another interesting question to get into is okay, so we know what BMI is, and we already know that's complex. Okay, how are you going to measure? How are you going to get from a face to this BMI prediction in the first place? And some algorithms do this directly by just you feed them thousands of photos of faces with a BMI, and then this algorithm learns to associate certain face types with certain body mass index scores. But that gets you really big models, so very large sets of data. So what you see that a lot of them do is they first boil down the face, simplify it to 7 ratios inside your face, and I'll go into those a little bit. So this is something you'll see a lot in face detection, face recognition software, which is this one's actually really simple. These are 68 landmarks in your face. So you'll recognize the eyes, the eyebrows, the nose, the mouth, and the outline of your chin. This is the 68 ones. This is very popular to base other things on. But there's another one, for example, that you've seen, which uses 128. So that's 128 features that more often used with creating face recognition software. So that's where you actually have this fingerprint concept. But this is very much about where are things on the face, and what they try to do is to get these 7 ratios from these 68 markers on your face. So you get things like this. For example, one of the ratios on the left is the outline of your chin in relation to the width of your face around your eyes. So if you have a fatter chin, that would mean that the outline would be larger, but the area around your eyes would still be the same. So then that might influence your body mind. That's what you would expect, and I can understand if you would expect that. Another one that you see in the middle is the fascinating one, which is the relationship between your eyebrows and your eyes. So apparently that says, I don't know. I guess I guess the idea is that if you are overweight, then it might droop down over your eyes. I really don't know, but this is one of these things that's one of the 7. And on the right you see another one which is more basic, which is the distance between your face at the middle and a little lower down in your face. So there are 7 of these. Here you see 6 of them, but there are 7, and well, it kind of depends. Some of them implement just 6. All the ones that I found that implement just 6, they use at least. Well, I'll get into all of them use this area of the outside of your chin versus the width of your face. But here you see a couple of them, like so your cheekbone width versus jaw width. We talked about that one. Your cheekbone width versus the upper facial height, which is interesting. We'll get to that next. So the average eye size, which I think, that's the one they mean above your eyes. There's the face height. So you see there are already two of them are related to the height of your face, which is interesting. And there's the one with the cheekbone width divided by the lower one that we saw. But so this is the kind of things that you see in the data. So you see the cheekbone width, and you see these names, these abbreviations for those scores, and they create these ratios so that you can compare people. Here you see an example of an image from one of these research papers. So some of these projects are actually academic research, so you can find more in-depth understanding of what they do. And what I kind of was hinting at before, and what you see, there's this interesting question here of, you see, one of the things they seem to need is the top of your face. But the thing is, as you saw before in this, right, there is no point for the top of your face. There isn't. So where do you get the top of your face? So what you see here is that they try to calculate where that kind of would be by using the points that they do have and trying to extrapolate from there. So here you see that they take the outside of your eye and then go through the middle of your eyebrow. They take that point, and then where they intersect, they assume is about the top of your face. But like I said in the video, that kind of implies that you can really affect what this algorithm sees as the top of your face by raising your eyebrows. And as we saw before, like 2 of these already use the top of your face. It's important to them. So you can kind of have some influence on the outcome by raising your eyebrows. And once you, of course, understand these ratios, you can influence quite a lot of it. Yeah, here you see how that would work. So by now you might be wondering, like, why those 7 ratios? Who came up with those 7 ratios? Like, where do those come from? So that's interesting. So there's this psychologist called David Coetzee, and he tries to, he's done research trying to find if there is a correlation between certain parts of your face and BMI. He was basically looking for it, try to see if it exists. So you see that all these, the most popular projects, which I think is where many of these ideas originate, for example, the Chinese academic projects, they refer to David's work. And they say, well, we're going to use the 7 things that he mentioned in his work as the basis for measuring the BMI. But then you find this little interesting thing where, all of them, as we've seen, all of them use the outside of your chin versus the width of your face. But what does David say about it in his own work? He says this, halfway down the line. He says, the perimeter to area ratio, which is that one that we're talking about, did not correlate significantly with BMI in any of the data sets. So actually, that one is like, he was doing his research and he said, well, that one, yeah, I tried that one. It didn't work. That one is not really correlating with anything. But still, you find that this one in almost all of the algorithms. So there's like another fundamental flaw in these algorithms, which is that they use a concept of measuring these 7 ratios where the very person who developed these 7 ratios says, don't use the one with the chin because it doesn't work. Okay, so let's go to another aspect of these things where you see how wonky it all is. So the question is, like, where do you get your data? Right? To train these algorithms, you need thousands and thousands of photos, and you need to have not just the photos of these faces, but you need to know the BMI for every face, which means you can either, you can calculate the BMI if you have someone's height and weight. So you can make the calculation yourself if you want, but you're going to need all that data. Where are you going to get that? So a very popular source for that is celebrities. So there are a lot of data sets out there that use celebrities. And then, of course, your question is, okay, celebrities, fine. But how then do you get the weight and the height of these celebrities? And there already it gets really interesting, because there was actually some scandals this year about how, for example, older actresses tend to lie about this stuff a lot. Otherwise, they won't get work. So that's a normal thing to do. But then, yeah, so then where if you get these pictures from the celebrities, where do you get their weight and size in the first place? Well, then there's at the bottom, you'll see these websites called celebheights.com and howtallis.org and celebsize.com. So basically, those websites are scraped, and then these researchers combine the photos from celebrities with the data from these websites to say, well, we suspect this celebrity has this and this weight and height and body mass index. So let's look at howtallis.org, for example. That these are really, really not scientific websites that try to, it's as unscientific as you can get. These are just people guessing and getting their data from, I don't know, articles. It's messy. It's really messy. So the data, if you're using celebrities, well, you're going to get very messy data to begin with. And that's the celebrity one is really popular. A fun fact that you find in a lot of these things that they'll try to see how well their algorithm is doing, and then suddenly Christian Bale is very popular. So Christian Bale, as you might know, has done a lot of movies in which he aggressively changes his weight to fit the role. So on the left, you see his face in The Machinist, and that's a movie where he lost a lot of weight to perform his role. That's widely stated what his weight was. So that becomes like a bit of a benchmark where he tries to, where he is used as a test for these systems. So that's the power of Christian Bale. Another thing that you'll find and that you might see in this picture is down the line at line 36, you'll see this little value called num inmates. And at first, when I saw these things, I wasn't sure what that num inmates. I saw, what does that mean? What's this all about? But then later on, as I learned more, I realized that that's because a lot of these, another popular source of images for training these algorithms are police arrests. So in the United States, if you get arrested, you don't even have to be, guilty. But if you're arrested, your picture will go up on these websites in some states, and those websites are basically scraped. And those are really popular. I of course, didn't want to show you photos, but those, when you think about it, those are great photos because you get a really front nice photo, and you get detailed measurements and probably correct measurements by the police of the weight and the age and all that stuff. So yeah, training these things on criminals or potential criminals, arrested people, let's say that, is also very popular. Like I said, another one is athletes. So there's a lot of websites where you can get these, for example, from the NBA and stuff like that, where you can get endless lists and photos of athletes, as well as their statistics, like their height and weight. And then you can calculate the BMI once again. And another source that I found, which is really baffling, is Reddit. So as you saw, there is this project by, well, not by Google originally. Well, when you look at it, it looks like Google did it. It says Google Research India Health. And if you look at the project in detail, the email address is an @Google address and all that. But, being a good journalist, I got in contact with them and asked them, is this an official Google project or not? And they said, no, it's actually more of a personal project with the researchers and we can't share it. But it looks a lot like it's a Google project. At the very least, it's made by researchers who work at Google. And as you can see, there are two files they use, which are called for Reddit and for old Reddit, which is where they scrape these Reddit. Where's my picture? Oh, sorry, it's not there. Where they scrape Reddit images, as you saw. So you have these forums where people say, well, look at me, I'm losing a lot of weight, and they have these before and after pictures. But they also have a standardized way of sharing that information, and that's very useful, of course, if you want to scrape it. So you can get this, you can take this standardized string of information, and then you can extract the new and age, the new weight and the previous weight. You can extract that automatically. So that makes it another interesting source for these algorithms. By now you might be wondering, so what data did I use? Because I made my own body mass prediction algorithm, and I have to admit it made me feel a bit dirty to do it, because I used some of these GitHub projects actually come with the photo data. They actually come with it. So I was surprised to find it, but then you got like this huge file on your hard drive, which is essentially, thousands of photos from arrest records that are on GitHub right now. So that's what I did. I took some of these arrest records, and I took a data set of celebrities that I found. And for the greater good, which is a horrible thing to say, because of course that's what all these people say as well. It's for the greater good. But I made my own algorithm, and that's what you experienced. And that's based on these celebrities and these people who were arrested. As a side note, like some other things I found online, it's funny, like we've been talking about faces right now, but I found one project that also tries to predict your body mass index from your entire body, which I guess actually makes a lot of sense. So you could imagine this could be used in security cameras and stuff like that. But yeah, that's kind of some of the sources of where this material comes from, and I hope that as we dove into this particular algorithm, what I think you see is that there's wonkiness and dubious things everywhere at every stage. So there's strange decisions in what to measure with the face ratios, which aren't really academic and strange. There's extremely wonky data being collected from all kinds of sources. So the judgments that are coming out of it can be extremely simplistic and not taking into account gender and all this stuff. And if you dive into this, and this is just one, right? We've just looked at one of these, but if you dive into this, you often find this dubiousness, which I guess you don't really know so if you were just a company and you say, hey, I want to use a body mass prediction index for service, and you upload people's photos and you get a BMI in return, you think, oh, well, that's fine. And I'm sure they've done it diligently and use correct data and all that. No, I don't think so. I think in a lot of cases, this stuff is really just scraped from whatever they could find. And I found like very strange calls for algorithms, for example, by an Indian company called Million Eyes, who are like, hey, can someone make a BMI prediction algorithm for us? We'll pay you this much. Just email it to us, etc. So it's it's a very strange industry, a very strange world to dive into. It's a very strange safari to go on, but I do highly recommend it. Like it is very sobering once you do. You really lose a lot of misconceptions about how trustworthy these algorithms are, because from what I can tell, they're really not. Okay, so there are some things I didn't go into in this project that I could have. Right, finally, so there are some algorithms that I could expand to, like in a later version, that I didn't. For example, this one is kind of a classic, which is that someone made an algorithm to predict whether or not you're gay or straight from a photograph. That was a bit of an issue a while ago. Another, by the way, an example in China is that in China, this whole idea of measuring your face to predict if you're a criminal is actually taken seriously again by some researchers. They're trying to do that. So that's again, I won't try to make an algorithm for that, but in China, they're trying to make one. This is another one that's kind of related to that. So this is a company that tries to predict what kind of person you are from just looking at your face again. So, to what extent does someone's face correlate to having a high IQ or being an academic researcher? So a lot of this is not just maybe your eyes, but also the things you wear and how you use your hair. Sure, it could learn from all those things, but the very fact that we're trying to, predict these type of things, knowing what I hope know about BMI, these things are very dubious. And if you try to predict something for an individual person, I think, this is going to be very, very unreliable, to say the least. But yeah, a terrorist, you can find out if someone is a terrorist, apparently, from looking at their face. Another one I didn't get into, but that I did actually have the code for, because I used it in another project, is ethnicity. So that's another thing where you can try to predict someone's ethnicity from their face, or are they Asian, are they African American, etc. So all these things can also be apparently, well, they cannot, but they are claimed to be able to measure from just your face. So yeah, what I going into the bigger picture of all this, this stuff is powerful, because not so much because it works, because I hope I made it kind of clear that it doesn't really work, and you've probably experienced this yourself. And this, when you were doing the How Normal Am I project, oftentimes it makes mistakes and it's not very accurate. But of course, the problem is that these things are taken very seriously nonetheless. As I said, these things are being used by insurance agencies, etc. Because a lot of people are not really asking the questions of, okay, but how was this constructed? Where was this algorithm made, etc. So that means that the validity of these things is highly overrated. And we have this desire almost to, well, not almost, we have this desire to base our choices on data, and it feels good to do that. I can imagine if you're working in an insurance agency, it feels good to say, well, we base it on data. But if your data is this wonky and this dubious, I don't know if we're really progressing anywhere. But yeah, it could still have a lot of effect on your opportunities in life. So this stuff is highly dubious, but also highly powerful. And I think that's something we really have to get to grips with more, and really look under the hood of these projects and ask these difficult questions about, like, okay, but how does this work? How was it constructed? Where did you get your data, etc. I think this also matters because this implementing these things and spreading these out a lot is creating this culture, for me, of surveillance, right? Where I saw a sticker a while ago on the lamppost that someone said, security cameras make me feel less secure. And I get what they mean, right? So of course, a lot of people will say, well, security cameras make me feel more secure. I get it. But I also, if I don't know who's watching them, if I don't know how the images from them is being analyzed, it also creates a risk for me that I have no control over, especially in public space. It's totally out of my control. So I totally get that. I think that for me, a lot of these systems don't make me feel better at all. They make me feel watched, and they make me feel judged, and I don't really enjoy that at all. And yeah, that of course, predictably brings us to this concept of the panopticon, right? So this idea that Jeremy Bentham had, who was a philosopher in the 1800s, if I'm right, or 1900s, and he had this idea for a type of prison where you would have one guard in the middle, and that guard would look at all the people, all the prisoners on the outside wall that were in the cells on the outside. And the idea was that the prisoners could not look at the guard because there was, for example, mirrored glass, or it was very dark in the guard room. So they would never know if they were being watched. But they always had to live with the assumption that they might be, right? They might be watched. And what Bentham said was, well, this will slowly ingrain this idea into the prisoner's mind. He will slowly start to ingrain this idea of, hey, is what I'm doing right now legal? Am I allowed to do this? And he thought that if they then left the prison, these prisoners would still have this idea ingrained in their brain of always thinking, hey, is what I'm doing right now, is that allowed? They would still feel watched after they left the prison in a way. We closed all these prisons for good reason, because not having any privacy nonstop is maddening, right? We've seen this time and time again. We've seen, for example, these journalists who tried to live under constant surveillance for 3 weeks here in the Netherlands. There was a great documentary about that. They had to stop the experiment after about 2 weeks because they couldn't take it anymore. And one of the guys said, I couldn't take being, I felt like I continuously had to be the best version of myself. And that was just so tiring. I couldn't do that. Right? So privacy gives us the opportunities to sometimes not be the best version of ourselves, to just be ourselves, be imperfect, which is what we are. Anyway, so that's what I worry about. I worry about how the proliferation of these technologies under really good intentions can have this subtle long-term effect that we're really not exploring well enough, where people do feel watched, and that has a subtle effect on people's character, on people's identity. And that has bigger implications as well, of course. If we create a society where everybody feels watched all the time, that can have serious consequences for people's political ambition or people's political willingness to say things, to speak out about things. I don't think a surveillance culture is a healthy culture. I don't think that's a culture that can sustain democracy well. So, bit by bit, like every time we install a new camera like this, it's like smoking a cigarette. Like, this one might not kill you, but you are, creating a problem by continuing on this journey. For me, it's also very much about not having any control over this. So, like I said, these systems are used to create profiles, which are, start with advertisers or these systems, and they end up in data brokers, and that data might then end up in all kinds of software for HR or insurance or border guards, or so there is this whole world underneath the surface that we don't see, where this data is proliferating, and where what a camera sees and what it judges you to be might end up in some kind of software that decides that you are not okay for a certain job. That's the world we're building. That's the world that's already to a degree been built under our feet. Yeah, so that's what I think is the bigger picture here, that this data is not just right now it's fun to look at, but this stuff is being used to judge us, to judge us as risks. In the end, they say that if you have a hammer, everything becomes a nail. Well, if you have data, then everything becomes a risk to be managed. And that, for me, is something we really have to avoid, and that this facial recognition technology is really a big hammer for that. That's we have to think about that more clearly, I think. So that's my point. That's how I want to end. For me, this project eventually is about trying to help my mom understand that these practical things of measuring faces, in the end, results in the development of a surveillance culture. Bit by bit, we're creating a world where we're being watched all the time, and I worry what that's going to do to all of us as individuals and as society. And I hope that by sharing this and showing you this, and by spreading this around, we can have this debate about the long term, about what the long-term issues around surveillance technology are, because we have to also talk about those. That's my talk. I hope you enjoyed it. I want to thank you for your time and your interest, and I hope you had a fun time doing How Normal Am I? And if you liked it, please help me spread the word, because this is the official launch. We just, it's live since about an hour. So yeah, let's go.